Okay, good morning, class. Today we look at this new chapter, okay, integration. Okay, integration, if you look at this lesson outcome, upon completion of this lesson, you should be able to evaluate integration by substitution, integration by parts, integration involving trigonometry function and exponential functions. Basically, all of this you have learned before you are here, right? So today it will be kind of revision. Okay, we will look at integration by substitution. And the function involves the trigo and also exponential functions. Okay. Differentiation is derivatives. Okay, differentiation is derivatives. So the integration is anti-derivatives. So integration is used to find areas, volumes, central points. Actually, you will see how to get this in EM2. Okay, and integration is a direct relationship between two variables. Okay, that can be found from the relationship involving rate of change. Okay, normally it involves the rate of change in engineering field. Okay, the simplest application of integration is area. When we are integrating this function from A to B, okay, this one from A to B, we are integrating this function with respect to x. That means what we obtain is actually the area under the curve. Okay, this is the simplest application of integration. Okay, these are the list of the formula for integration of trigonometric function. Okay, trigo function, hyperbolic function, Bond function, exponential function. Okay, now we will look at some of a number of examples that use the integration by substitution. Okay, we look at this. Secant square 3x minus 5. Okay. Examples, I think I will just write on the board so that you can see the steps. The steps to get the answer. Three x minus 5. Okay, this is a trigo function. Okay, we will let the angle, okay, to be u. We will let the angle function to be u. Okay, so when we use u, means that after the substitution, everything will be changed from x into u. Okay, no more x later. Okay, no more x. Everything will be in u. So if that is our u, we will have secant square u, right? Okay, secant square u. This is our u. And dx, we want to change dx. Okay, so you have to find for du dx, which is 3. If we want only dx, we want dx from 3, you move it to the left. Then we get dx. So your dx is 1/3 du. Okay, so you see, after we change everything in u, no more x. You change in one step. You can't have x and u in one integral. Okay. So this 1/3 you can factorize. So you are integrating the secant square u with respect to u. So integrate secant square, we get tangent. Okay, tangent. So tangent u plus c, because this is infinite integral. Infinite integral means when you didn't see the limit, okay, that is infinite integral, and you need to have a plus c, okay, for your answer. Okay, and finally, you have to change the u back into x because this is in x. So your u is 3x minus 5 plus c. Okay, so this is the answer. So I repeat once again, this one, okay, a triple function, we let the angle to be u. Okay, then we start to change from x into u. So this is secant square u. This is your u. And we want to change the x into u as well. So from here, we differentiate u with respect to x. So we have du dx. So here we have a 3. If we want only the x here, so the x goes up, this one goes to the left, it will be 1 over 3 du. Okay, so we replace the dx by 1 over 3 du, factorize the constant, so you are integrating secant square u with respect to u. So integrate secant square, you get a tangent u. Okay, and finally change back u into x. Okay, so integration by substitution. Any question? Now, then we look at the second example. Okay. So for this question, we have two choices. When you take the function to be your u, you have two choices. Either you let this x, either you let the u to be this term x, or you can let your u to be the whole function of the denominator. Okay, I will show you both of this, and let's see what's the difference between these two. Okay, so let's say I start from this one. Okay, the slide, that one, it follows this. Okay, so when you have beside the function, okay, we will start to change into u. So we have 2 plus u. 2 plus u. Okay, we want the x. Okay, we want the x. So from here, we will this one use the implicit differentiation. Okay, square both sides. Square both sides, and we use implicit differentiation. Differentiate this with respect to x. What do you get? Last time you have y squared equals to x. Now we have u squared equals to x. They are the same. This is not x, but we need to differentiate this one with respect to x. So we differentiate this one with respect to u. Then followed by. Okay. Okay, what we want? We want the x. Okay, we want the x. So 2u du is your dx. Okay, then replace the dx by 2u du. 2u du. Okay, meaning that you have this 2u over 2 plus u du. Okay, to integrate this one, we have to apply the long division because this is power of 1, this is power of 1. Suppose the power of the denominator should be greater than the nominator, but now this is same. Okay, when this is the same or this one greater than this, we have to apply the long division. Have you learned about the long division? 2u divided by 2 plus u. Learned this before? No? This one should be maybe matrix diploma, SDBM. I'm not sure whether secondary school got this. Okay, this is actually same with the division. Okay, division. Okay, to get 2u, we have to multiply 2. Okay, this 2 plus u actually is the same with u plus 2, right? 2 plus u is the same with u plus 2. So now we multiply the 2 to this function. You have 2u plus 4. So this function minus this function, 2u minus 2u, no more u. 0 minus 4, you get a negative 4. So this will be equals to 2. This is remainder minus 4 over u plus 2. Okay, then we will start to integrate with respect to u. So 2, we get 2u. Okay, minus, we factorize the 4, you are integrating this. Okay, when you are integrating this, that means you get a lot. Because when you differentiate this, you get 1. When you differentiate this, you get 1. So the answer will be log this function. Okay, and finally, you have to change your u back into x. Okay, so this will be 2u minus 4 log u plus 2 plus c. Okay. Okay, got it? Now we look at another case. If we choose u plus 2, u equals to 2 plus certain x. If we choose this to be your u, what's that? Okay. So this one, it will be changed into 1 over u. Okay, 1 over u. And we need the x. We need the x. So from here, du. Okay, we do not want to find du dx directly because of this. Okay, this is the sub x. Later, when you differentiate this one, you get the power of negative half. So you can do this first. U minus 2 equals to sub x, and we square both sides. Okay, because we want to avoid to have the 1 over sub x after the differentiation. So we use implicit differentiation. Okay, then from here, differentiate this with respect to u. Okay, times differentiate this one, you get 1, and then du dx equals to 1. Okay, what we want? We want dx. So your dx goes up, you have 2u minus 4 du equals to dx. Okay, 2u minus 4 du, dx goes here. So your dx will be this one. Okay, this is your u, so your dx will be this. 2u minus 4 du. Okay, so this one divided by u means 2u over u minus 4 over u. Cancel out the u, you have 2. So integrate 2 with respect to u, you get 2u. Okay, minus 4, factorize the 4, you are integrating 1 over u, that's been log u. Okay, plus c. Then we change the u back into x. So 2, this is your u, minus 4 log u plus x plus c. Okay, this is the answer for this case. This is the answer for this case. But actually, there are both of these two, they are the same. Okay, this one, if I expand, when I expand, we see the extra terms of this 4, right? If you compare that one with this, we have an extra term of 4. This 4, actually we can combine with this because this is constant, this is also constant. Constant plus constant, we get a new constant. So this one, actually we can write this as plus C, where this C is 4 plus C. It's been another C. Okay, so basically you can stop here. Okay, this is acceptable. Okay, but when you further simplify, you will see that actually they are the same. Okay. Any questions? Any questions? So actually from this example, we can see that which one is simple? This one is simpler, right? This one, we take the denominator function as our u. Okay, for this kind of case. Okay, for this kind of case. Okay. This one, we will let the denominator function to be our u, x squared plus 7. Okay, so this one, x equals to 2, x equals to 4. These two values are x. So x equals to 2, x equals to 4. Now we want to change into u. So it must be new values. So when x is 2, your u will be 11. When x is 4, your u will be 23. So your new value will be 11 to 23. This is for u. Okay, then x squared plus 7 is our u. So what is left? You have x dx. Okay, you still have x dx. After we change this into u, this one into u, you still have x dx. So from here, du dx is 2x. We want x dx. We do not want 2. You move it to the left. So this is our x dx. This one. So you replace x dx by half du. Half du. So this one will be 1. Okay, then we factorize the constant. You integrate 1 over u, you get ln u. 11 to 23. Okay. That's mean ln 23 minus ln 11. Then you get this 0.36 double A. Okay.
How you get okay.
Differentiate du dx. Differentiate u with respect to x. Okay, we want the x dx here just because after we change everything that we can change into u, it's left x dx. So we want to change the x dx into something in u. Okay, so we need to have x dx here. We found the x dx here. Then we found that this is half u. So we replace this by half u. This is x equals to 2, x equals to 4. When you change into u, this must be u. So when your x is 2, okay, when your x is 2, substitute x by 2, you get your u. Substitute x by 4, you get your new u. Okay, any more questions? The working is on the it's given in the slide. Okay, this one we let u to be the power of exponential function 1 minus 2t. Okay, now we start to change. Okay, we have a 2, we have exponential, then this is our u now. Okay, then we need the dt. Okay, find the dt from here. du dt is -2. Okay, we want only dt, so this one move to the left, this one move to the right. So our dt is -half du. So -half du for this dt. Okay, so cancel out the 2, factorize the negative, integrate eu with respect to u, you get eu plus c. Okay, change the u back into t, then you get the answer. Okay. Any question? Okay, next one. This is similar to the previous, I think the first two or first three. Okay. Okay, this is similar to the question just now 1/2 plus sub x. So we have two choices. Either you choose this to be your u, or you choose the whole function as your u. Okay, so as what you have saw just now, you have already saw just now, I give you two cases where we choose this one to be u and this one to be u. You see the difference. When we choose only this one, we need a log division in the integration. When we choose the whole denominator function, it will be easier. Okay, so this question, I will use this as your u. Okay, then and we can start to change into u. So this is your u. Now we want the x. We want the x. So we have to get the dx from here, but to avoid to have the surd, we will move the 2 to the left. And we square both sides. Okay, we square both sides. Then we use implicit differentiation. So 2u minus 2 power of 1, and then times 1, then du dx. Okay, we want the x. Okay, we want the x. So this is our dx. Okay, this is 2u minus 4 over u. So we separate this into 2, will be 2u over u minus 4 over u. Okay, so cancel out the u, you have 2 minus 4 over u du. Okay, then we can start to integrate. You have 2u minus, factorize the 4. So 1 over u, you get ln u. Then finally, you change your u back into x. Okay, any questions? Okay, I will skip this. I want to start the exercise first. Okay. And what is your u? Your u should be the denominator function. Okay, denominator function. X cubed plus 4x. You can now start to change all x into u. What's the sign 1 minutes? What's the sign 1 minute? Okay, step by step. Okay, this one is your u. This is your u. But you do not write 12x squared plus 16 dx here because we cannot have one integral that contains x and u. Okay, so just change this one into u first, and then we will see what we need. We need this. After you change this into u, there are still some x terms. So we want to change the x term into u from here. So get your du dx first. Your du dx is 3x squared plus 4. Okay, this dx we can move to the 3x squared plus 4 dx. And now come back to this one. We need what we need. This is 12x squared plus 16 dx. But this is what we have. So what we do? What we do? Factorize. You factorize, sir? Factorize? What value? You factorize of 4, right?
Yeah.
Okay. So here, when you factorize of 4, this one, factorize of 4, you have 3x squared plus 4 dx. Okay. So you can factorize the 4. Okay, you can factorize the 4. And this one you replace by du. Okay, or here you can multiply a 4. Okay, multiply a 4 so that you have 12x squared plus 16 dx. And here will be 4 du. Either way. Okay, so if you can't see this, okay, you can do like this. 4 du equals to 4 dx squared plus 4 dx. Then we will have 12x squared plus 16 dx. That will be 4 du. 4 du. Okay, then you can proceed to integrate. Proceed to integrate, then change your u back into x. Okay, number 2. Any more questions? Number 1. Okay, let me look at number 2. Number 2 is similar to number 1. Okay, what's the u for number 2? Do you take together the power of 4? No, we don't take the power of 4. Okay, trying to change x between u. For integration by substitution, when we use for the u function, it will be kind of trial and error. Okay, trial and error. This one, why we do not take the power of 4 together? This will be answered when you start the try. You can try, take the 4, then you will see what happens later. You can't get to change all x into u. Okay. You want the suitable function to be u in order for you to change all the x into u. And remember, for this integration by substitution, it's aiming to change after the change from x into u, it must be in a simpler form. Okay, why we use integration by substitution? Because after we change into u, the integral is simpler than the original one. If after change from x into u, you found that your integral is much complicated compared to the original one, that's it, we don't use it's pointless to use the substitution. Okay, so this is your u power of 4. U power of 4. Then we need this. We need this. Okay, then we get this from there. du dx is 2x plus 3. So your du is 2x plus 3 dx. But what we need is 4x plus 6. Okay, so either you factorize here or you multiply a 2 here. When you multiply, you have to multiply both sides. Okay, then we have 4x plus 6 here. Okay, so this will be 2 du. Either way, okay, either you factorize from here, you get a 2, or you multiply 2 on both sides. Okay, when you see this is the same as this one, then this will be replaced by 2 du. 2 du. How to integrate? Factorize the 2, change this into this. Then power plus 1 divided by the new power. Okay, if you use this way, when you multiply a 2 on the right, you have to multiply a 2 on the left. Okay, when you multiply something, you have to do it, apply it on both sides. Okay,
Good.
this is U. Okay, negative, that means negative, that means here U power of 3. Okay, U power of 3. Okay, this one U negative 3. When you see negative, that means the U power of 3 is here. Okay, U power of 3. It gives me power in power. Any more questions for number 2? Okay, when you are integrating x cubed respect to x, how do you solve this? Power plus 1 over 4, right? This is also the same. Power plus 1, you get negative 3. Divides the new power at the bottom by this one. After you plus 1, then you divide it by the new power at the bottom. Okay, so this one plus 1, you get a negative 3. Any more questions? Okay, now we look at number 3. Okay, number 3, what is your U? You take the 1 minus 3x squared, or you take the square root of 1 minus 3x squared. Okay, this one, you can choose 1 minus 3x squared or the surd of 1 minus 3x squared. Okay, you can choose either one. But you will get the same answer. Okay. Try to change first. Okay, the third 1 minus 3x squared is your u, and we need an x dx. Okay, we need an x dx. So we get it from here. Okay, now we get rid the square root by square both sides. Apply the implicit differentiation to u du dx. It is negative 6x. Okay, here we want only x dx. Okay, we want only x dx. So we want x dx. We do not want negative 6. So negative 6, you move it to the left. So you have 2u over negative 6 u. That's means negative u over 3u, which is your x dx. Then substitute the x dx by this one. Factorize the negative 1 over 3, cancel out the u. Any questions? Okay, proceed to number 4. Okay, what is your U? What is your U?
15 and 5x.
Okay, you can either choose 5x cubed plus 4 as your U, or you take this as your U. Either one. I think this one would be easier. This one may be easier. Okay, so this one, x is 0, x is 2. So you need to find what the new U values. Okay, then substitute one by one. Okay, when x is 0, U is 4. When x is 2, 44. That means 4 to 44. Okay. So here, this is your U. The U power of 1 over 4. This is power of 1 over 4. And then we still have this. Okay, we still have this. So the 2, you can factorize the 2. Okay, you can factorize the 2 here so that we need another x squared dx. So the x squared dx you can get from here, x squared dx, that's means 15. Move it to the left, then we get the x squared dx. We factorize the 1/15. Then we can start to integrate this. U1/4. Okay, so to integrate this, power plus 1. Power plus 1 over new power. Okay. So this 4, you can bring it up. Okay, this 4, you can bring it up. Okay, so 4, we factorize this 4/5. Then we substitute 44 into the U. Okay, so this will be 8/75. Any questions? Okay, number 5. What is the U?
As
X power of 4 plus 6x. Okay, try to change the x into U. Okay. X is 1, x is 2, find what a U. Okay, when x is 1, your u will be 7. Okay, when x is 1. When x is 2, when the 8, 7 to 28. Okay, this is your u cube. Okay, u cube. Now, we need this. Okay, we need this. So what we need to do, we need only the 2x cubed plus 3. So we have 4x cubed plus 6. So here we factorize. We factorize 2. Okay, factorize the 2 and we move the 2 to the left. Any questions? Okay, now we look at number 6. Okay, what is your u for number 6? 3x squared. 3x squared minus 9x. Okay, so x is 0, x is pi. Okay, this one you can also change into 4 decimal places. Okay, because I didn't bring my calculator, so I just leave it in this form. Okay, so you can use also 4 decimal places for it. Okay, so this one, this is your sine u. Okay, this is your sine u. So we still need this one and this one. Okay, so differentiate. Okay, we need only 2x minus 3, but here we have 6x minus 9. So we can factorize 3. Okay, we can factorize 3. The x move to the right. Okay, but we do not want the 3. So just move it to the left. Then you can start to replace your 2x minus 3 dx. Okay, you can also use this. Okay, so factorize the 1/3. And when you are integrating sine u with respect to u, you get a negative cos u. Okay. This one you can use this 1.3325. Okay, I bring out the negative before substitution. Next, number 7. Okay, number 7, what is your u?
Okay,
5x minus 2. You can also choose the sum of 5x minus 2. Okay, so you have a sum u, and you need this. Okay, we can get the dx from here. Okay, if you can get the dx, okay, we can get the dx from here. But how about this x? How about this x? Dx is this one. So your x in terms of u, okay, we want an x in terms of u. Okay, simplify. Okay, here we have over 5. Over 5. So 5, we get a 25. Okay, so u plus 2 is here. This is u power of half. So we can expand. So u, this is u power of 1. So 1 plus half, you get 3 over 2. And then 2u power of half. And we can start to do the integration. So u, this 1 plus 1 over 5 over 2. Okay, over 5 over 2. The 2, I bring it up. And 2u, okay, 1 over 2 plus 1, 3 over 2. So 3 over 2, bring up the 2. Plus c. So you have the 2 over 1, 2, 5 u 5/2 plus 4/75 U3/2 plus C. And finally, you change your U back into X. Any question? Number 7. Okay, no question. Proceed to number 8. Okay, your U will be
X2 minus 3x.
okay, the denominator function. Okay, then you can start to differentiate and substitute all the x into U. Okay, we need x squared minus 1. Okay, we need x squared minus 1, so factorize the 3. And we move the 3 to the left. Important. Okay. Number 9, what is your U? You're correct. Okay, this is sine x cubed. This is sine x cubed. So our U will be sine x. The x is cos of x. And try to change from x into u. And you bring the cube together, later you will find that you are unable to shift all the x into u. So we have u cubed, and we make this. We get it from here. Okay, this is u cubed, and we need a cos x dx from that. Okay, any more questions for number 9? All right, number 10. Okay, number 10, what is your U? Okay, you change your tangent x into sin x over cos x, then you will know what is your U. What's your U? Cos x. Okay, that's one. Number 11. Any more questions for number 10? Okay, number 11, we let the u to be the denominator function. If you move the 3 to the left, then we square both sides, and we will find the same differentiation. Okay, if you differentiate du dx starting from here, you will get the set of x plus 1 later. Okay, it will be, it works, but it will be more complicated compared to the one that you use implicit differentiation. Because when you use implicit differentiation, we do not have the square root. You can start to apply the implicit differentiation. Okay, we have 2. Okay, 2 over u dx. We want dx. Okay, actually you can choose other function to be your u, and you will see what is the difference between the other one with this one. Okay, there are more than one. Okay, there's more than one choices for your u. Okay. You can choose any u as long as that you manage to let you change all the x into u. Then you can use that u. Okay, but after you change, okay, if this is simpler than this, then you are successfully choosing the suitable u. If after you change, it looks more complicated, that means maybe you can find another key. Okay, or you didn't manage to change all the x into u, that means that you can't use. Okay, this number 12, I will continue in the next class because this one, we have to use the substitution of the trigonometric functions. Okay, so this one, we will look at this in the next class. Okay, so any questions before we end the class? If no, then I will see you this Thursday.
Yeah, next week online next week.
Next week? Next week? Tuesday or Thursday? Tuesday will be still face-to-face class, but next Thursday I will leave. Okay, no class for the next Thursday, but next Tuesday we still have face-to-face class. Are you guys still here next Tuesday? How many of you will come for the physical class on next Tuesday? Hands up. I want to see how many of you next week, Tuesday, then you will still come for the physical class. Next Tuesday, I want to know how many of you will come for the physical class next Tuesday. Hands up. Okay, so next Tuesday we still have physical class.